So the container theory, according to which the embryo or the fetus are contained inside the pregnant mother, and it seems to me to be absolutely trivial and obvious that the embryo or fetus is contained inside the pregnant mother, but there is a small literary tradition. I think this is not the earliest piece, but it's the earliest piece which is easy to find on the web. You can see what it means. So the paper explores the issues and ethical and professional responsibilities of social workers with respect to unwanted medical treatment of pregnant women under the guise of child protection. The thesis is that there is no child there to be protected, it's just a part of the mother. And 1 year later, are pregnant women are, that is to say they have fetuses in their bodies, but the implications from this fact drawn by some people that women are nothing but cheap clay pots supporting infinitely precious flowers is far from being the case. Women carry fetuses, but that's because fetuses are parts of their body. And then this paper argues that a particular metaphysical model permeates cultural practices surrounding pregnancy, the fetal container model, and the only work which explicitly attempts to justify this model is this paper that I wrote with Berit Brogard. And now, of course, the reason why this is the only paper is because it's obvious. And so no one else would even bother to write a defense of such a view. And this is... And the paper is based on other papers defining the idea of containment. And the idea of containment extends way, way beyond just the relation between the fetus and the mother. It includes practically all of biology, and many other things, of course. So we are at the moment contained in this room, and the room is contained in this building, and the building is contained in Amherst, and so forth. And the axioms governing this notion of containment and the niche, which is the container, are presented in this paper, and in a second paper also written by Achille Varzi, which is about the idea of surroundings. What does it mean to be surrounded by something when you're an organism in an environment? So you're surrounded by a forest, you're surrounded. And the basic idea is what we call the double hole structure. So a bear is in the cave. The cave is a hole with an H. And the place inside the cave which is occupied by the bear is a hole inside that hole. And that hole, when the bear moves around inside his cave, then the hole moves with him. And the same applies to a fish swimming in the ocean. And what we need here is some kind of physical boundary, which we call the retainer, and then a medium, which in this case is air, it might be water, and then the bear inside the niche is a tenant, and then we have a niche, an empty niche, when the bear leaves his cave to go hunting. And then there are 4 kinds of niche, which we distinguish here. So one involves a more go hunting. And then there are 4 kinds of niche, which we distinguish here. So one involves a more or less complete spherical or topologically spherical boundary around the niche. We will talk a lot about eggs later on. When I say more or less complete, a chicken's egg has, I believe, something like 16,000 pores in it. And the same applies to other birds' eggs. So it's not complete in the sense in which, for instance, a hollow metal sphere is a complete boundary around a hole with an H. But it's complete in the relevant ecological sense. And then a trench would be, as illustrated under heading number 2, and a field is just a flat niche And the environment then is a kind of hemisphere, niche of a flying buzzard, or the niche of a whale swimming through the ocean. This would be a niche which doesn't have any retainer of the physical sort at all. It's just median, or any immediate retainer. And so eggs, wombs, coffins, and so on are examples here. Fridges with the door closed. We'll talk about all of these examples as we go along. And the point about them is that they give you high protection. So it took a long time for safes to be invented, for instance, to protect valuables. And it's generally a mark of civilization that you have high protection, because that means you're very clever. Because there is one downside of high protection, which is that it's difficult to escape if your environment catches fire, or if a predator surrounds it, for instance. And they gradually solved the problem of high protection, not allowing a driver involved in an accident to escape the effects of the accident. But in 2000 they haven't solved that problem. This example will also play a big role in what follows, you'll be pleased to hear. In fact, we can't get rid of him. All right, so this gentleman here is contained in, but he is not a part of the spaceship. And that's the fetus, of course. The fetus is contained in, but not a part of the mother. And there are many similarities here. So the astronaut is connected to the spaceship by means of things which look a bit like umbilical cords. This is not contained in and not a part of the spaceship. So this is the baby when the umbilical cord has not yet been cut. This is the ontology I'm going to be defending, the obvious ontology. All right, protection, but you can just jump out. You can escape very easily. And now, it's clearly wrong to say that the mother is a fetal container. The mother contains a fetal container. And that fetal container has within it a cavity which forms the niche of the embryo or fetus. And that niche is of type 1. In other words, it offers high protection. It took a long evolutionary process to reach the point where we had that kind of high protection. So the mother is not a fetal container, she is a protectrix. And that it's a wonderful achievement that we have achieved this position of being able to protect the unborn human. Like a fridge. So a fridge provides protection for the yogurt which it contains. And not just protection, but temperature control. It regulates its environment, provides a safe space, but it doesn't provide oxygen and food to the yogurt. So that's the difference between the fridge and the mother. And just in passing, this is an example of intelligent design. So there is intelligent design, and it's what designers do. They design fridges. It took a long time for human beings to invent these things and perfect them. The mother is also a food processing plant, because unlike the fridge, the mother does provide food and oxygen and waste removal and so forth for the baby. And the mother is a green prenatal intensive care unit. You can measure civilizations according to the age at which the youth leave the protection of their parents. So now we have safe spaces, so we extended it even beyond the usual level of high school. But the first stages in that protection of the young, the unborn, is inside the mother. The mother is providing protection. All right, in a regulated environment, and then the home becomes a regulated environment. The mother is inside the home, so you have two layers of regulation, two layers of protection. You have the protection provided by the mother, and you have then the protection provided for the mother, and therefore through the mother for the fetus or the embryo by the home, and then you have the police patrolling the streets, who are providing protection to the home, and so on. It spreads outwards. Then you have the space provided for the mother, and therefore through the mother for the fetus or the embryo by the home. And then you have the police patrolling the streets, who are providing protection to the home, and so on. It spreads outwards. Then you have the space force protecting the whole planet. All right, now there is, of course, a complicated relationship of regulation, but it's more complicated than just regulation, between the mother and the baby. And this is in part an immunological relationship. And I like this paper because it shows how difficult it is actually to prove on the basis of microbiology that the fetus is not a part of the mother. Because we like to think that if you have a kidney transplant, then after a tumor, and I think we like to think that a tumor inside your body is not a part of your body. Now the tumor shares DNA with you, it's mutated, but it's still your DNA. The fetus and the embryo share 50% of the DNA with you if you're the mother. I'm assuming that applies to everyone in the room. But the immunological relationship between the mother and the fetus or embryo is actually much more like that of the tumor than it is like that of the graft. So the graft gives rise to high levels of antigens. It doesn't want to be there. It's attacking its new environment. And that's why huge amounts of drugs are involved in order to make the graft take. Now, in the tumor and the early pregnancy phase, there is a relatively low level of antigens. It gets more interesting as time goes by. So there are 4 stages. There is the stage where the blastocyst is just floating free, and then gradually the blastocyst becomes attached to the epithelium of the uterus, and then gradually it penetrates and becomes implanted in the uterus. Now, through these phases, there is a relatively low level of immune response. Everyone, the mother and the fetus, the mother and the embryo are not attacking each other. But once we get to the stage of implantation, there is a huge immune response, a huge inflammation, which is exactly like what happens with the tumor. The free-floating tumor, what happens with the tumor. The free-floating tumor is not giving rise to a very strong immune response. But once it starts not just attaching, but invading into the relevant part of the body, then you have inflammation. So there are 3 immunological stages of pregnancy, therefore, measured by this inflammation phenomenon. There's the first trimester where you have high inflammation, second trimester when things settle down again, and then third trimester where inflammation once again raises its head. And now, the Elseline Kingma, who is the world's leading authority on this false view, makes us a nation during the whole of these 3 phases of pregnancy. And so she argues that the baby is part of the mother because the baby is connected to the placenta and the placenta is connected to the mother. And if you're inside the mother and connected to the mother, then you are therefore part of the mother. That's the thesis. And so her paper is called Lady Parts. I like this paper for a number of reasons. So this is another study, but it's a study of how implantation evolved. Why do we have implantation? Implantation is obviously a good thing if we like protection. And so it was an evolutionary victory to have implantation. Where did it come from? One reason why I like this paper is because it uses the gene ontology in order to make its argument. The gene ontology is one of the victory to have implantation. Where did it come from? One reason why I like this paper is because it uses the gene ontology in order to make its argument. The gene ontology is one of the ontologies which we use in Buffalo in our work with biomedical informatics people. So this is a picture of the genes which are overexpressed in non-pregnant organisms. And these are a picture of the genes which are overexpressed in the pre-attachment phase in pregnant organisms of the same kind. And if you look closely, you will see that after attachment you have many genes which are responsible for evolution, for immune response. So they've been excited. These genes are enriched. They are expressing themselves because in post-inflammation response the mother is trying to fight off this thing which is invading her, roughly speaking. And this is a study of the opossum. Now that's very important because opossums are not placental mammals. They are marsupials. And they share with placental mammals attachment and inflammation, but they don't share with placental mammals the subsequent anti-inflammatory phase, the normal phase of the happy phase of pregnancy, when the fetus is developing inside the mother. In other words, they stop the protection here. They stop the interior protection. What do? Well, you have to watch a video now. And there is sound, but I don't. Wallaby Joey. Wallaby Joey, it's a few millimeters in size. Already it has very developed hands. And that's because it's going to climb up its mother's belly. It protects it again. But in a much... All right, so her whole argument breaks. And so I'm not sure she's done it yet, but she has been warned that she should stress that this only works for placental mammals. It doesn't even work for other kinds of mammals. She wants to say that the relationship between the embryo, the fetus on the one hand, and the mother is like the relationship between the cat and its tail. So the tail of the cat is a part of the cat, and so the fetus is just the end bit of the tail. Here, this is what her presentation. But unfortunately, there are three kinds of mammals. There are mammals which lay eggs, and that's three kinds of protection. So there's type 1 protection in the egg form, which is outside the mother. There's protection in the egg form, which is outside the mother. There's type 2 protection, which is the pouch form, the niche type 2, and then there's type 1 protection again, which is inside the mother, which is a kind of triple 1 protection, because you have the wall of the cavity within which the fetus embryo is contained, and you have the external skin membrane of the mother, and you have all the protection associated with the mother. So there is a common ancestral population of these three kinds of mammals. The key is the beginning of lactation. That's why we're called mammals, because we have mammary glands. Then the creation of the yolk sac and the placenta for these two kinds of mammals, but not for monotremes. And the placenta in the marsupials is very rudimentary. And our common ancestor in the marsupials is very rudimentary. And our common ancestor is in fact the ancestral amniote. That's the first species which had an amnion, and therefore an amniotic cavity. And this includes reptiles and birds and crocodiles, turtles, and so on, and mammals. And then various other the dinosaurs and so on, but we don't need to bother so much about dinosaurs today. And that's another picture. So basically we'll be interested in birds and humans. So if you look at the definition of amniotes, then they are defined as organisms which lay their eggs on land or retain the fertilized egg within the mother. Now, I think that's a very significant statement, since we are amniotes. So you saw the yolk from the marsupial. This is an interior view of a bird's egg. This is at an earlier stage. This is at a later stage. So that's a chicken. And this is a view of a reptile egg, and you can see it's very similar to a bird's egg. It has the same pores and so forth. Has an amnion, amniotic cavity, and then the embryo inside the amniotic cavity. And then we have similarities between reptiles and birds on the one hand, and placental mammals on the other hand. So the umbilical cord is much more significant here. But we have the yolk sac in both cases, and so forth. The embryo is the same. Chorion is not laying animals, but we are egg-producing animals, which are only in very subtle ways different from the other egg-producing animals, including reptiles and birds, and marsupials. So, all of us are such that our mothers utilize a certain kind of containment for the purposes of protection of the embryo or fetus. All mammals, all reptiles, all birds have a process for doing this which is ontologically very similar, at least. And in each case it involves a certain kind of capsule which keeps the embryo or fetus separate from but close to the mother. And it may be an egg, or it may be a pouch, or it may be the multi-layered structure which we're familiar with involving the placenta. All right, so this is what it looks like in the case of birds. So the eggs are close to the mother. And this is what it looks like in the case of marsupials. And birds are egg layers. Mammalian mothers are, I want to call them egg harborers. So it's not a containment view, it's a harboring view. Or egg havens. Or, since we're